Hello. As I receive a lot of questions regarding the cooking pot antenna for the L-band, just a few words about the antenna. Originally, the antenna was designed by Matjaž Widmar, so all credits to him. He called the antenna a cup, but it's more like a cooking pot by the size. I will tell you. So basically we have a metal reflector and the cross dipole to obtain the circular polarization that we need. The reflector, the size of the reflector is quite flexible. The diameter of the antenna is 1.1 to 1.4 wavelength, and the depth of the reflector is 0.5 to 0.6 wavelength. So the height of the rim of the reflector. In my case, for the L-band, center frequency 1545, I use the diameter of 24 centimeter or 240 millimeters, and the height of the rim is 10 centimeters. Of course, I use aluminum, and this is not a cooking pot, but it's originally the cover of the microwave link, and the measures are quite good for the reflector for the L-band. The dipole, I'm using the cross dipole, and we can see the distance from the reflector. It's exactly quarter wavelength, and the cross dipole size is 0.52 wavelength and 0.42 wavelength. To achieve the circular polarization, we use that trick. Otherwise, we will have a linear polarization, and the wire going down from the reflector to the dipole is pulse stub. As we have the coaxial feed line, 50 ohm hard feed line, unbalanced feed line, and we have a balanced symmetrical dipole. So I'm using a quarter wave pulse stub. The length, in my case, the length of the longer dipole is 50 millimeters, and the short one is 40 millimeters. It is important how you connect so this is L that is connected to the hot wire or center pin of the coax, and this L is connected to the ground or to the shield of the coaxial line, and of course the pulse stub is connected to the hot wire, to the short one. It is important the orientation of the long and short part of the dipoles. So this is the short dipole, and this is the long one, and this is the wires. These are the wires connected to the center line. With this position, we achieve the right-hand circular polarization. If we just flip this side of the longer dipole on the other, vice versa, we will have the left-hand circular polarization. So take care when you are doing when you are making the antenna about the dipole assembly. On the other side, we have just the 50 ohm connector. This is the SMA and nothing else. So 50 ohms line and the cross dipole with the pulse stub. The gain of the antenna should be 12 dBi, circular polarization, and it should be about 4 to 5 dB better than using a patch antenna. The advantage of this antenna is it's quite robust, and to protect the antenna you can put plexi, thin plexi, or some other RF transparent material, and the antenna should be perfectly protected from the rain or from the ice. Actually, this was the original idea from the Matthias Widmer, to have a very robust antenna for the microwave bands. So that's it. You can use, of course, the cooking pot for the reflector, and you should have a good results using a metal reflector, aluminum or aluminium, whatever, or copper if you prefer. So that's it. Cooking pot antenna for the L-band, the 9A4 Queen Vector.